Hi guys, today we're going to go over 1.4, which is solving systems of linear equations. So it's in the word, everything here linear. We're going to be talking about lines. Okay, so solving, this is going to be a big topic in Algebra 2. What does solving mean, right? So we'll have either if we have one line, we're going to have it intersect the x axis. If there's multiple lines, we'll have them intersect each other. Okay. So there's three ways that we're going to go about solving these guys. The first way is graphing. Okay, so we'll graph. You could do the number of lines that you have. So we'll say graph all lines and see where they all intersect. Okay, so they all have to hit at the same exact point. Most of the time in this class, we'll be just talking about two lines, so that makes it a lot easier. Okay, our next two are going to be substitution and elimination. You've seen them before, but we're going to just practice with them again. Okay, so with elimination, we're going to try to cancel one variable out. Once we've canceled the one variable out, we solve for the other. Once we've found that the other variable, then we're going to go back. So we'll go back and plug in, okay. Substitute, we'll substitute in, plug in to find first variable. Cool. Now substitution, just as it sounds, like if a teacher has a substitute, you bring in a new teacher to fill the spot, right? So substitution, we're going to plug one equation into the other. Cool. Okay, so on this first one here, as we go through it, says by graphing, so solve it by graphing and using elimination. Okay, the only time you have to do a certain way is if we specify it like this. If we ever just say solve, you can choose any of the three that you want. Okay. So we can go either route. I might do elimination first on this one, and we'll just see how it goes. So the way I always recommend is look at your x's and your y's, right? Are there any, starting out right away, if I add the two equations together, do they disappear? And yep, on my y's, so if I add these two equations together, we add straight down, we end up with 5x, and now these guys eliminate. Right, because we have a plus 2y and a minus 2y, so they eliminate each other, and so well, bam, we got what we wanted. Okay, so then added the 4 and the 6, we get 10. Now solve it. So we solve for x and we get 2. So that's our first step of elimination, is to get rid of one to solve for the other. Now we plug this guy, x equal to 2, back into one of the two. Okay, you can choose either one that you want. Right, I always recommend try to find the easiest one. So I personally would, I don't know, I would probably try the bottom one. So I'm going to substitute an x of 2 in there. So I'm going to get 2 minus 2y is equal to 6. And now we're just going to solve for y, right? So subtract the 2, negative 2y is equal to 4, divide by negative 2, so y is equal to negative 2. Okay. The way that we write our answer is not like this, where we have an x and a y. It's a coordinate point. So our real answer is going to be the x first and then the y. So this is our answer, 2, negative 2. So we want to write it as a coordinate point. Okay. Now in order to graph it now, okay, I'll put nice pretty colors. there's two ways you can go about this. Number one, you can graph from slope-intercept form, and then another one you can graph here from standard form. So I'm going to show you both of them. Okay, so this first one, the way that we would solve it is we want to put it in slope-intercept form. So we want to get the y by itself. Okay, so that means I'm going to subtract 4x to both sides. So we end up with 2y is equal to, I know that what I'm trying to get is this equation here. We're trying to get y is equal to mx plus b. So I want the x to come first, right? So I'm going to put that negative 4x first plus our b value, which in this case is 4. So now divide by 2 by everybody. So y is equal to negative 2x plus 2. Cool. And we graph that. So this is our y-intercept at 2. And our slope is at negative 2. So that means fall 2, run 1. Okay. Now do a few of these points because I don't know where the intersection is going to be, but we actually do. It's going to be this guy, 2, negative 2. So I'm going to do a few points just so that I can have a nice clean intersecting point. And then you got a nice line like this. Well, bam. And that's your first graph. Okay. Now let's choose a different color. What should we do? We'll do purple. Okay. So purple, I'm going to bring it down here. So now with this equation, another cool method to do is just solving from standard form here. And so this gives us our intersecting points. Okay. So our intersecting points. So if I want the x-intercept, okay, what that means is that y is equal to 0. So that guy cancels out this y. So we end up with, this one cancels out, and so we end up with just x is equal to 6. So my x-intercept is at 6. 1, 2, 3, 4, 5, 6. Now another method, or not same method, but now to find the y-intercept, we say that x is equal to 0. So we go back to our original equation, and we say that x is now equal to 0, so he goes away. And so now I have negative 2y is equal to 6. Solve for y. So y is equal to negative 3. Okay, and then negative 3. So those are my 2 points. Now we can look and we kind of guess that it's going to go through this point, but we're not totally sure. So in order to find our slope, just to make sure, remember it's going to be rise. So rise of 3, run of 1, 2, 3, 4, 5, 6. So rise of 3 over run. So our slope is actually 1/2. Okay. So our slope is 1/2. And so we can go through here, rise 1, run 2. Holy smokes, there's our intersecting point. Okay. So if you notice, that is our answer, which just happens to be 2, negative 2. Right? So this guy here matches this guy down here. Okay. Whole lot of work. Typically when you do these, you're not going to try to solve it with multiple methods. Okay, so we're just doing this to kind of give you the idea of a few different ways to solve these. Okay. Now B, if you look, this one looks super similar, but neither one here is going to cancel out, right? So neither one cancels out, but I can multiply one of the two to have them cancel. So I'm going to multiply the bottom equation. I notice these are like same thing here, but they're the same exact signs. I actually want them to be opposite signs, so I'm going to multiply by a negative 1. Okay, and so my top equation didn't do anything. Now my bottom equation, I'm just going to change all the signs on here. So I just changed all the signs, plus 6. And I add straight down, right? So add, those guys just happen to cancel. These guys end up happening cancel. So I'm not left with anything on the left-hand side, and the right side is equal to 18. Okay, and so this one, when you have all your variables cancel from the very beginning, you have 2 options. It's either no solution or infinite many solutions. But since we can tell here, none of this doesn't make sense. 0 does not equal 18, so therefore my answer is going to be no solution. Solution. Okay. That's my answer. Well, so what does that look like graphically, right? So if I come back and I graph both of these, this top one, we're going to go through, you can do either way. I kind of like doing from standard form, but either way works well for these, right? So my x-intercept, that means that y goes away. So the y goes away. And so I'm left with 6x is equal to 12. So x is equal to 2. Okay, so x is equal to 2. Here, for my y-intercept, we go back, we bring y back, and we get rid of the x. So I have negative 3y is equal to 12. So that way, y is equal to negative 4. Okay, so my y-intercept is negative 4. Okay, and if you notice, my slope here is going to be rise of 4, run of 2. So my slope is 2. Okay, so I can kind of connect the dots here. Now when I graph the next one here, we do the same exact thing. My x-intercept and my y-intercept. So my x-intercept for the second equation, we ignore the y. So we end up with 6x is equal to negative 6. Solve for x, which is negative 1. So in the x, it's negative 1. Now when I come back and solve for y, I get rid of the x. And so I get negative 3y is equal to negative 6. Divide by negative 3. So y is equal to 2. And if you notice, our slope here is 2 over 1, which is 2. If you notice, this guy matches that guy. All right, so these, if my lines were straight, are two parallel lines, right? So I told you at the beginning of the lesson, our solution is where they intersect each other, right? And so two parallel lines will never intersect each other, so that's why we call it no solution, okay? Okay. Now we're switching it up, and it says, okay, just do it by substitution. Okay. So if we just do it by substitution, this one's really nice because we already have the x variable by itself, right? So what that means is I'm going to put what x is equal into, and I plug it into the x value of the second equation. I just replace it, right? So don't put it next to it. Literally replace that x with that. So when I substitute in, I get 3. I substitute this whole thing in, plus 4y equals 6. Cool. And once I've done that, now I'm going to solve, right? So I distribute in, I use our buddy PEMDAS or SADMEP, right? So I'm on the same side, so I'm going to use PEMDAS. So negative 6y minus 6 plus 4y is equal to 6. I'm still on the same side, so I just combine like terms. So negative 2y minus 6 is equal to 6. Now I'm moving stuff from one side to the other, so now I use that idea of SADMEP, right? So I add 6, negative 2y is equal to 12. Negative 2, and so y is equal to negative 6. I'm saying PEMDAS and SADMEP. You guys would probably remember PEMDAS. That's the way to solve if you're on one side of the equals, to simplify, and then to solve, I'll do little back and forth arrows. If I want to solve, if you looked at the first video, I kind of talked about doing the opposite operation. Okay, so the opposite operation would be this guy backwards. And so you'll hear me say SADMEP a lot. Okay, your teacher may not say that, which is totally fine. They may talk about the opposite operation a lot. Okay, so now I've got the y value. So now I'm going to take this and plug it back in to get my x value. So I have x is equal to -2. Now I'm going to substitute back in, and I have this is now -6 minus 2. Okay, and then simplify it. So this is what, 12 minus 2, which is 10. So my answer, my final answer is going to be the x value first, even though I solved for y first, x value first, comma, the y. So that's your answer. So our two graphs would intersect at the point 10, -6. Okay. So I'm not going to show you all of these. I'm going to let you look at this one on the notes. It's the same idea. This one you just have to solve for it. Okay, so this one, it says use substitution or elimination. It's totally up to you. Okay, so I'll show you this one because this one's another unique one, but check number 3 out on the notes, filled out notes online. Okay, so here it says graph and do whatever method you want. So I'm going to do elimination just because the way that it's set up, right? So if you look at example number 2 that we just did, the x was already by itself. So that made my life really easy. Here, the x's or the y is not by itself. They're kind of combined together, okay? So what you could do is you want to look and see, okay, are these easily, will they cancel out easily? No. And another thing that I notice is this is kind of in a weird order. The top equation goes x, y equals a number, and then the bottom goes y, x equals a number. So the first thing I want to do is make them look the same. So I'm going to move that second equation, and I'm going to just switch the position. So I'm going to do 4x minus y is equal to 2. So I just switched the 2. So now I'm going to look and see, okay, what can I multiply top and or bottom, because you can multiply both of them. But if I notice here, if I multiplied the bottom by -3, the y's will cancel, right? Because there'll be a -3 and a +3. So that's what I'm going to try. So the top I didn't do anything to. And then the bottom I multiplied everybody by -3. So this just happens to come out like this. Equals -6. Now we add them together. These guys cancel. These guys cancel. So it leaves me with nothing on the left-hand side. And then the right-hand side, these guys cancel and also leaves me with nothing, right? So on this equation, if we notice, this was very similar to the first one, one of the first ones that we did on B on page 8. But this time they come out to match each other, right? So they match each other. So 0 equals 0. So therefore this one is what we call infinite. Many solutions. Okay, and then for short, we're going to call it IMS. So I won't go too in depth just because of time with graphing these, but you'll notice if we do the same method that we did for a couple of the other graphs, that we'll come across these guys. What would that be? These guys would end up being parallel lines, or not parallel, sorry, on top of it. So these guys, if you look, they would be, there'd be a point here, and so both graphs, both the blue and we'll call it green, would just be on top of each other. Okay, so here you notice with one little side note, that doesn't intersect a nice point, it intersects at a half. So these guys you might want to just put into slope-intercept form like we did on the first example. Okay, cool. Now these, very similar. The only difference here is it says solve the inequality, right? So inequalities back with these greater than and less than symbols, okay? So if you notice, we're still going to do the same idea of that substitution, we are not going to do substitution elimination. We are going to graph these guys, and then we're going to shade, right? And so the shading, where they both shade is going to be our answer. Okay, so if we graph this first one, right, it's nice because it's already set up in slope-intercept form. So our y-intercept's at -3, and then our slope is at 2. So rise 2, run 1. Okay, I'm going to do just a couple more just in case. Now, a couple things here is if it's greater than or less than, we have a dotted line. If it's greater than and equal to, less than or equal to, it's going to be a solid line. Oops, solid line. Okay, so this first one, since it's just greater than, it's going to be a dotted line. And then our second one here, the blue one, he's going to start at 2, and then his slope is at -3, so 1, 2, 3, 1. Woohoo! We intersect right there. Now it's a solid line since it's equal to. Okay. And on the previous example, this would have been our answer, right? But since it's an inequality, remember an inequality gives you a bunch of answers, right? Gives you a range of answers. So now what we need to do is go back and we need to test a couple points, okay, to see which side are my answers. Are they over here, to the left, or to the right? Okay, so for the green guy, you're going to test a point, right? You could test any point you want that's not on the line. So what I'm going to do is I'm going to test this point right here, 0, 0. That's the easiest one if we can, right? So if it's not on the line. So I'm going to test 0, 0, and what that means is just literally plug 0 in for x and 0 in for y. So if I plug 0 in for y for the top equation, I have 0 is greater than. If I plug 0 into here, that goes away, and I'm left with -3. Now, is 0 greater than -3? Yes, that's true. Okay. Now here, this is where some students get a little confused. So since I tested on this side of the line and it came out true, that means I shade on the same exact side. I shade all my stuff here. Okay. Now I come back and do the same thing, but for the blue line. I'm going to see, can I test 0, 0 again? And I can because it's not on the blue line, so I can test it. So I have 0 is less than or equal to, this goes away because it's 0 again, 2. Sorry, 0 is less than 2, so that's true again. Okay, so since it's true, here's my blue line, and then I tested on this side, so that means I shade on this side. Okay, and so your answer is where the shading overlaps each other. So my answer is right in here, okay? And I'll clean this up a little bit, but that's where my answer is going to be. So I'm going to go back. So my answer was in this area right here. So that is my answer to this inequality. Cool. Okay, so number 6, I'm going to show you kind of the same exact process, but a little bit different because this is kind of how I do it, so I don't have to go back and erase a bunch of stuff. So I'll do this one first, just because it's it's already in slope-intercept form. So it says go up to 1 for my y-intercept. My slope is 1/2, so rise 1, run 2. Rise 1, run 2. We'll do a couple of these. Now it says it's a solid line. So I do a solid line through here because it's equal to. And now what I do to make it a little bit shorter, I'll test a point. Again, it doesn't go through 0, 0, so I'm going to test that point right there. So if I test 0, 0, I come back, I get 0 is greater than, the x goes away, 1. Well, is 0 greater than 1? No, that's not true, so it's false. Okay, so I tested the point underneath the line here. It came back and it said, that's not true, it's false. So since we do that, we jump to the other side. So what I'm going to do is I'm going to write myself a little note right here. I'm going to say shade above the line. So I should do all this shading right here, but I don't like to go back and do a bunch of erasing. So I just make myself a little hint right there and say, okay, all the shading is above the blue line. Okay, now come back to the green line. And this guy, you can either do standard form or slope intercept. I'll do slope intercept since I showed a bunch of standard forms earlier. So minus 2x, minus 2x. So negative 4y is greater than or equal to negative 2x plus 8. Now this is one of the tricky things with inequalities is remember when you divide by a negative, that inequality switches directions. So now it's y is less than or equal to 2 negatives, so those go away. So we have 1/2 x minus 2. So if you notice, the slopes are very, very similar, right? So now we're at negative 2, and my slope is 1/2. Okay, it's a solid line because it's equal to, and you have 2 parallel lines. Okay, so now I have to test the green guy. Okay, so if I test the green guy, so he also doesn't go through 0, 0. So I'm going to test 0, 0. And so the nice part about this is that goes away. That goes away and leaves me with nothing on the left-hand side is equal to 8. Okay, is 0 greater than 8? No, so that is false. So whenever it's false, whatever side you tested, you jump to the other side of the line. So what it tells me is this guy should be shaded down here. The blue guy should be shaded up here. Now, do they ever intersect each other? No, one's on top, one's on the bottom, so this one comes back to another no solution. Okay, so there's no solution because the shading doesn't intersect each other. Okay, for these next two, I'm not going to go through, just it's kind of a longer video, so I'm not going to go through this whole thing, but I'll just set up for you. Okay, so typically it's just the setup that takes a lot of work. Okay, for these guys. So an ice cream shop, one customer pays $7 for 2 sundaes and 2 milkshakes. Okay, so I'm going to call this one sundaes and milkshakes. Okay, a second customer pays $11 for 2 sundaes and 4 milkshakes. Right, so how much does 1 sundae cost? How much does 1 milkshake cost? So what we're going to do is set it up. So $7 is equal to 2 sundaes plus 2 milkshakes. Our second customer came in and paid a total of $11 for 2 sundaes and 4 milkshakes. Okay. So at this point, what I would do is look at these guys. These would be super easy to cancel. So maybe multiply this whole thing by -1. And so you end up with 7 is equal to 2s plus 2m. Didn't do anything to the top equation. Now we multiplied everybody by a negative in the bottom, so we changed the signs. Okay, add it straight down, so -4 is equal to, these guys cancel, -2m. Now divide by -2. So a milkshake costs you $2. Okay. Now come back here, plug it in here, and solve for the sundae. Cool. Number 8, the ACT prep. We will set this one up again, and then I might not solve it, but you can check out the filled out solutions on our notes. Okay, so X, we're going to say we have 2 sizes. We have the large figurines, so X will be large. Y will be small figurines. Okay, so Cami sold 70 figurines in 2 sizes. So the way we're going to do that is X plus Y. So the large and the small figurines, Cami sold a total of 70 of those. Okay, this is the number. So number of small, number of large. Now we're going to talk about cost. So the large cost $12. Okay, so 12x. And the small cost $8. so plus $8, for a total of, did it say? The large figurine sold for, and the small figurine, the amount of money it received for the sales of the large figurines was equal to, oh, I went too fast. So it says the amount of money received for the large figurines was equal to the small figurines, okay? So they didn't give us a total amount. They said these, when put together, were equal. Okay, so those guys were equal. Now you can go about this any way that you want. I might do, I feel more comfortable with elimination on this one. So with elimination, what you'd want to do is bring that 8y over so that the x and the y are in the same spot. So we would have x plus y equals 70, and then this guy would be 12x minus 8y is equal to 0. Now you need to have these guys match. I think I would multiply the top by 8 to have the y's cancel. So we have 8x plus 8y is equal to 560, right? Because I multiplied the two together. And so this is, 12x. So this is now 12x minus 8y is equal to 0. We didn't do anything to the bottom equation. We add them together. These guys cancel, so we have 20x is equal to 560. Divide by 20. So x comes out to be 28. And then go back and plug this into either one. I would probably plug it into this guy and figure out your y value. Okay? Thanks a lot for watching.